Solving systems of linear inequalities. The steps for solving a system of linear inequalities is first to rewrite both inequalities in slope-intercept form. Then graph one of the lines. If this inequality includes an or equals, graph a solid line. If the inequality does not include an or equals, graph a dotted line. Check one point to see which side you should shade. Draw an arrow on the side that should be shaded. Now graph the second inequality and mark its shaded side with an arrow. Where the arrows overlap, that is the solution to the system. That is the area to shade. There are several examples on this page of your notes. We won't go over them right now, but you can review them later. We will begin on the next page. In this first example, y is greater than or equal to negative x plus 4. 4 is our y-intercept. We start at 4, and the slope for this line is negative 1 over 1. So we're going down 1 and right 1. There is a line under the inequality symbol which means or equals, so this is a solid line. Now test which side of the line should be shaded. I'm going to test the point 0, 0 for this line. Put a 0 in for y and a 0 in for x. 0 is greater than or equal to 4. This is a false statement, so I need to draw an arrow away from the point 0, 0. Now graph the second inequality. This one has a y-intercept at negative 1 and a slope of 3 over 1, up 3 and right 1. This one also has an or equals symbol, so is a solid line. Anytime you see a line under the symbol, it is a solid line. Now I'm going to test the point 0, 0 again. Notice it is just to the left of the line, right here. 0 is greater than or equal to 3 times 0 minus 1. 0 is greater than or equal to negative 1. This is a true statement, so I'm going to shade towards the point 0, 0. Where the arrows overlap is the solution to the system. Darken the shading here. Erase the other arrows. The shaded area is our solution, and we have finished. Pause here and try this example yourself. Now that you have tried it yourself, you can check your work. This time we will have two dotted lines because neither of these symbols has an or equals underneath it. The first line begins at negative 3. The slope is up 5 to the right 3. Draw a dotted line. Now test the point 0, 0. 0 is less than negative 3 is a false statement. Draw an arrow away from 0, 0. The second line begins at 3. The slope is up 1, right 3. Once again, we draw a dotted line. Test the point 0, 0. 0 is less than 3 is a true statement. Draw arrows towards the point 0, 0. Shade where the arrows overlap. This is the solution. Everything in the shaded area makes both inequalities true. In this example, you will need to convert the inequalities into slope-intercept form before you can begin. 3x minus 2y is less than or equal to 2. Subtract 3x from both sides. Negative 2y is less than or equal to negative 3x plus 2. Divide both sides by negative 2. Watch out right here. You need to turn the inequality around because we have divided by a negative. Whenever you divide by a negative, you need to turn the inequality around. Y is greater than or equal to positive 3/2 x minus 1. Graph this inequality. Start at -1, up 3, right 2. This one is a solid line because there's an or equals symbol under the inequality. Now test the point 0, 0. Choose the original equation to test it in, not the one you just made up. 3 times 0 minus 2 times 0 is less than or equal to 2. 0 is less than or equal to 2. This is a true statement. Draw arrows pointing towards the tested point 0, 0. Now convert the second equation into slope-intercept form. X plus 2y is less than 6. Subtract x from both sides. Divide both sides by a positive 2. This time we do not turn around the inequality because we divided by a positive. Y is less than -1/2 x plus 3. Start at positive 3. Go down 1, right 2. This one is a dotted line because there is no line under the inequality symbol. Test the point 0, 0 in the original equation. 0 plus 2 times 0 is less than 6. 0 is less than 6. This is a true statement. This means the arrow needs to point towards the point 0, 0. The solution is where the arrows overlap. Shade this area. The shaded area is the solution to the inequality. Pause the video and try the last example yourself. Now that you have tried it, check your work. First, x equals a -3 is a vertical line. Draw a dotted line at -3. Test the point 0, 0. Put in a 0 for x. 0 is greater than -3 is a true statement. Draw arrows pointing towards 0, 0. The second line needs to be converted into slope-intercept form. Subtract x from both sides. Divide both sides by 3. We are dividing by a positive, so we do not turn around the inequality. Y is less than or equal to -1/3 x plus 1. This line will be a solid line. Start at 1, go down 1, and right 3. Draw a solid line. Test the point 0, 0 in the original equation. Zero plus 3 times 0 is less than or equal to 3. 0 is less than or equal to 3. This is a true statement. This means you draw arrows pointing towards 0, 0. Everywhere that is shaded makes both inequalities true. The dotted line means that the points on the line are not included in the solution. The solid line means that the points on this line that are touching the shading are included in the solution. Please feel free to use these notes as you complete your homework. Thank you.